All right, section 1.6. We learned about lines and angles and points and all that kind of stuff earlier. We're going to kind of put a lot of that together today, and we're going to talk about a thing called a polygon. You might have heard that word before. They're shapes, yeah. Okay, so a polygon is basically just a shape. So here's a shape right there. All right. Now, what makes it a polygon? Well, let's talk about this. Polygon, first of all, doesn't have any curved sides. Okay. It has to be closed in, all right? All the sides have to be made up of line segments, okay? And all the line segments, they connect or they intersect the other line segment at their endpoints. Do you see that? So it's not like this line just keeps on going, all right? They're line segments, and at each endpoint, they intersect another line segment. And it's a closed figure. There's no gaps in it. There's no openings in it, all right? It's a closed figure. Each one of these line segments is called a side. You've got angles, you've got sides, and at each endpoint it intersects, okay? So that line segment doesn't keep on going like this. So that makes that thing a polygon. Basically, polygon means many angles. Poly means many, okay? You've probably heard that prefix before, haven't you? For poly, right? And the gon is talking about angles. So it's many angles. But it's more than just many angles. It's specifically line segments that connect at the endpoints, and it's a closed figure. All right, there's no curves around it. Daniel, this is why you're not hearing what I say. So get your head up and write stuff down. Write stuff down. So let's do this. Each one of these things right here is called a side. And where they connect, like right there, that's a point. Okay, where those endpoints connect, it's called a vertex. And we've talked about a vertex of an angle, haven't we? Well, that's a vertex of a polygon. But a polygon doesn't just have one vertex. This particular polygon has how many vertex? 1, 2, 3, 4, 5, 6. So 6 of them. So we say, instead of just one vertex, we need a plural, because there's 6 vertex, right? So we don't say vertexes. Okay, we say vertices. Very good. Okay, it's vertices. That's the plural. I'll put PL in front of it, okay? So the plural of vertex is vertices. Again, we're learning words, okay? We'll do that all year, learn new words, and that's what that is, okay? So you have 6 vertices. Now watch this. That means you have how many sides? 1, 2, 3, 4, 5, 6. We have 6 vertices, we have 6 sides. How many angles are formed here? 1, 2, 3, 4, 5, what? 6. So if there's 6 sides, there's 6 angles, right? And there's 6 vertices. Make sense? That works with all polygons. It has the same number of angles as it has sides. And we could name it. Let's put, at each of these points, let's put a capital letter. Now again, let's use capital letters. I thought I was very, very clear on this when we first started talking about it, but I still, on quizzes, I see people writing lowercase letters for points. I see people writing it in cursive. Don't write it in cursive. If that's your thing, change it to print, okay? All right? I'm just telling you. Change, when you write letters, change it to print and change it to capital letters. These points should be capital letters, all right? Don't use a lowercase letter because geometry becomes very specific. Lowercase letters mean a certain thing. Uppercase letters mean a certain thing, all right? So make sure that you label things properly. So this is a polygon. Now we don't have any kind of like fancy symbol for polygon. What we would do is we would just say and write the word polygon, or, and we'll talk about specifically, somebody already mentioned this, that 6 sides is a hexagon. We'll talk about that in a few minutes here. But we would just say polygon. There's no like symbol for polygon. But you do have to label it correctly. You could start at any of these vertices. There's really no starting point to this. So you could start at any of them. You don't have to put it in alphabetical order. I don't know, sometimes I kind of like to just kind of make things a little nicer. So you could start at A if you wanted to. And you could go either direction. You could go B, C, D, F, or you could go what? A, what do you think? F, E, D, C, B. You can't do this, though. You got to go around the horn, right? You got to go around it in consecutive order. You can't skip around and say, oh, this is polygon A, C, F, D, E, B. You follow me? See, did you follow the pointing thing? Okay. Yeah, Summer? You do have to name them all, okay? So, now they're not going to give you something with 100 sides and you have to name it, all right? They're not going to be ridiculous. But, yeah, if you wanted to name this thing, you name all the points, all right? take any one of them. You don't have to start at A. You could start at any of these points, but you have to go, and it doesn't matter what direction, but you got to go in order around the polygon. Does that make sense? So I can't skip across. I can't go A, then D. I got two choices if I start with A. I could go A, what? B around, or I could go A, F around. All right, let's just go B. That'd be a little nicer, wouldn't it? So if I go A to B, what would my next one have to be? C, then D, E, and F. Now, I could sit here and name, there's probably a bunch of different names that you can name this one particular polygon. I mean, I could have started with C, couldn't I? And I could have started at C and said, what? This is polygon CDEFAB. Or I could have gone the other way and said it's CBAFED. You got it? So, you could sit here and do all kinds of different names for this. But if it's me, I kind of like to go in alphabetical order. If it's written in alphabetical order, right? A lot of times they do. And I kind of like to start with the A if we got an A there. All right? But you don't have to. There's all kinds of different ways you could call this. But you use the word polygon. There's no like crazy symbol or anything for this thing. Does that make sense? All right, that's pretty easy. Now let's talk about the difference. I'll tell you what, let's talk about the difference between two types of polygons. This one right here, we'll use this again because this demonstrates this one type of polygon. And this is called a convex polygon. Convex polygon. Because, I'll show you, here's a little test to see if it's a convex polygon or not. If I was to, I'll just extend the sides. I want to extend all the sides of this polygon, and I'll just show that with a dotted line. Alright, so if I took this side and I extended it out, it would go that way and it would go this way. You with me on that? Then I'm going to take this side and extend that out, and I'll just show that. Oops. Okay, like that. Follow me? I extended that side. They're supposed to be straight, Give me a little break here. And then if I extended this side, it would go like this. If I extended this side, see what I'm doing? All I'm doing is taking all 6 sides and I'm extending all the sides. Take this one, and I'm extending it, and one more, right? Take this one, extend it like this, extend it like this. I think I've extended all the sides, haven't I? Notice, all those extensions, all those dotted lines right there, they do meet, don't they? Eventually, they'll meet. But where do they meet? Do they meet inside the polygon or outside the polygon? Outside the polygon, that's right. None of these extensions actually go through the center of this polygon or through the polygon at all, does it? They all go through the outside. That's one little test to see if it's convex or not. So this would be a convex polygon, because if I extend all the sides will go outside the polygon. Make sense? All right. So I said there's two types, convex, and I actually have one already pre-drawn, I think. Let me, yep, here it is. So instead of drawing it, copy and paste it and drop this down. So I got convex. Anybody in science class remember when you talked about lenses and things like that, there was a convex lens, like glasses. One of the sides is convex and the other is, any idea? Anybody learn anything like that, like in 9th grade science? No? Concave, do you ever hear of that?
Nope.
You never heard of that? That's all right. Now you have. Now you can't say you haven't. All right, so it's concave. It's supposed to be an A. Concave. This is a concave polygon. Now remember the other one. The other one, if we extended the sides, all the sides went outside the polygon. Let's try to do the same test with this. Let's extend this side right here. Well, so far they go outside the polygon, don't they? Let's extend this side. So that's outside. That's outside. Okay, so far so good, right? Take this side right here and extend it. That goes outside, but watch what happens here. I take this side and extend it this way. Oops. Look what it does. It goes what? It goes inside it, doesn't it? Alright, so if it goes inside the polygon, when I extend those sides, and if it goes inside the polygon, guess what kind of polygon we have? Concave polygon. And it does it with this one too, doesn't it? If I extend that out. Alright, so right in here and right in here, that tells me that's a concave polygon. If you look at it, let's look at it again. If you look at it, can you just look at it and tell the difference between concave and convex?
Yeah.
It kind of bends in towards the inside of the polygon, doesn't it? That other one did what? It goes all outside it, doesn't it? Alright, so this one, it kind of bends in towards inside that polygon, so that's concave. So you should just be able to look at it. So do you really have to sit there and extend all the sides to tell if it's convex or concave? Probably not. You should just be able to look at it and say, oh look, all these, you know, are facing outside. Oh, look at these two sides. These two sides are going in towards each other into the polygon, so that would be concave. All right, not that big of a deal. It's not going to be a huge deal to know the difference between concave and convex. They may ask you in a homework problem to just tell the difference between one or the other. Okay, it's not a real huge deal, but it's interesting to know. All right, let's do this one. I got another picture that I want to find. Got it over here somewhere. Let's see which one I want to pick. Oh, I thought it was over there. Maybe it's on the other side. Ah, there it is. Let's do that one. I could have picked any of those. Now look at this. Is that a polygon? Yeah. Is it concave or convex? Convex, right? Because none of the sides are like pointing in towards the everything's going outside. See how that point's kind of pointing outside, 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 outside. So it's convex. But there's something special about this one. Now when I drew this originally, I drew this so that all the sides are equal to each other. Okay? But that's not the only thing that's true about this. All the sides are equal, but I made this so that all the angles, very good, all the angles are also equal to each other. So this is kind of a special polygon, and we give it a name. We call it a regular polygon. You'd think it'd have a cooler name than that, right? It's just a regular polygon. All right. So if something's a regular polygon, two things are true. What are the two things? All the sides are what? Equal, or we could say in geometry we say congruent a lot of times, and all the what? Angles are congruent. I showed you that before, right? The congruent thing? Yeah. Yep. A little squiggly on top of an equal sign. All right, so that's congruent. So that makes a regular polygon. Now that's going to be very important. Today we're not going to do a ton of stuff with a regular polygon. Let me just double check. No. On another lesson though, maybe even in another chapter, I don't even think it's in this chapter, but in another chapter we're going to do a lot of stuff with a regular polygon. All right, we're going to get really detailed, and we're going to do a lot of things with a regular polygon. We're going to actually figure out what these angles are actually equal to. Okay, if I know how many sides and if I know it's a regular polygon, we're going to figure out how many degrees each of those angles actually is or are, whatever you use there. Okay, so so that's another lesson. We're just right now, just understand that that is a regular polygon. All right. Let's see what else I want to do. Oh, let's do this. If I just said, well, a regular has both of those things true, right? But what if just the sides were equal to each other? Let's say the angles were not equal to each other, just the sides, and only the sides were equal to each other. I would call that equilateral. Good. Lateral means sides. All right, so that would be an equilateral polygon. All right, so if only the sides were equal, I would call it equilateral. And you could have one that all the sides are equal, but the angles are not necessarily equal. I don't have one drawn like that for this, but take my word, you could. All right, they might have one in the book, maybe not. So if all the sides are equal, it's equilateral. What if only the angles were equal to each other and not the sides? What if all the angles were equal but the sides were not all equal to each other? We wouldn't call it equilateral because lateral means sides. We would call it equiangular, right? Because angles. Equilibrium, is that what you said? Equiangular, all right, because of angles. All right, so we would call this an equiangular polygon. And we're going to get into that a lot when we talk about triangles. We'll have a whole entire chapter on triangles. At least a chapter on triangles. In fact, we actually have a chapter that's just on right triangles. A whole entire chapter is just on right triangles. Could you even believe that they could even have enough information? Well, there's even more than just a chapter on right triangles. In fact, they have whole courses called trigonometry that deals with triangles and right triangles and things like that. Okay, so anyway, there you go. But right now, if just the sides were equal, it would be equilateral. If only the angles were equal, it would be equiangular. If both of those things were true, then we would call it a regular polygon. Everybody good with that? All right. Now, what we're going to do is stuff that you probably did back in 3rd, 4th, 5th grade. I can't remember exactly what grade you did this in. But, oops, I need a picture here. So I got these pictures already pre-drawn. Yeah, let's use a triangle. Oh, you know what? Did I go over the names of these things? I didn't. I got to do that. I got to do that. Let's go to the bottom again. There we go. Alright, so let's do this. I'm not going to put a picture here just yet. But let's say we have some polygons, and here's the number of sides, and here's the name. We have special names for some of these polygons. Not for everyone, but for a lot of them we do. Especially the lower numbers. So if we have 3 sides, you already know what that. What's the name of a polygon with 3 sides? It's a triangle. Very good. And all these start with that prefix, don't they? These start with the prefix for what that number works with. So tri means 3. Angles, obviously. Triangle, 3 angles, right? So what if you had 4, though? This is where people... Yeah, very good. It's a quadrilateral. A lot of people say, oh, it's a square. It's a rectangle. Well, square and a rectangle is a special type of quadrilateral. But just any old 4 sides would be a quadrilateral. Quadrilateral. What did I say lateral means again? Sides. Lateral means sides. Okay? Quad meaning 4, right? So quadrilateral, 4 sides, right? It doesn't mean all the sides have to be equal or right angles and stuff. It could be just any 4-sided polygon is a quadrilateral. Got it? So is a square a quadrilateral? Is it? Yes, it is. Is a rectangle a quadrilateral? Yeah, absolutely. All right. So what about 5? The last picture we did. Yeah. Pentagon. We all know about the Pentagon in D.C., right? Yeah, got blown up. And just celebrated the 10th anniversary, and they showed a lot of that on TV and stuff. And why do they call it a pentagon? Because what's the shape of the building? It's 5 sides, exactly right. Okay, there's 5 sides. And it's actually, I believe, if I'm correct on this, I believe it's a regular pentagon as well. Because all the angles. So if you go to the Pentagon, carry around a protractor and put it up against the... No, probably want to do that. You probably get frisked or something, and they probably take it away from you. All right. So what about 6? What's the name for 6? Right. So you've learned these before, haven't you? Yeah. You probably learned these when you were like in an English class for the prefixes. Right. Good. So hexagon. It's supposed to be an E. 7's one that you don't see too much. Yeah. I think they use heptagon on this one. I taught out of a book years ago that they had this whole list, and they would call this a 7-gon. So they have all these names for it, and then all of a sudden stuck in there they just say, this is a 7-gon. All right?
That's crazy.
Yeah. So anyway, but heptagon would be a... and then, now 8's very familiar. It's an octagon. So it's an octagon. And what do we see almost every day, probably? Stop sign is an octagon. It's not just any old octagon. Guess what it is? It's a regular octagon. That's right. So you could probably do this, but you don't want to do this on a busy street. But take your protractor, go up to a stop sign. You don't carry your protractor with you? Oh, my goodness. What's wrong with you? So go up to a stop sign, stick it out there, and you can measure all the angles of a stop sign, and then take your ruler, measure all the sides, and all the sides would be exactly the same, okay? Well, actually, my summer job, back in the day when I was in college, my summer job, I had the same summer job all my years at college, and I put up signs. Do you remember that? Did I tell you that? Yep, and so I dealt with octagons a lot, and so I know all about them. I know all about octagons. All right. Yeah, we call this a nonagon. It's supposed to be an O. Non-a-gon. That's 9. And then 10 is a decagon. That's kind of a deca. Right? What do we use a lot when we talk about deca? Prefix deca. Years. What about years? 10 years. Decade. Right, a decade. I think they give you a name for 11, don't they? You hardly ever hear this. In fact, I gotta look it up because I don't even know. Hendecagon. See, I would have never. I haven't either. What did I say? Decagon. Decagon. All right, and then 12. We'll stop at 12. It's kind of cool sounding one. What is this called? It's a dodecagon. Dodecagon. It does. All right. Anyway, so there you go. Hendecagon and dodecagon. But really, the important ones. Triangle, quadrilateral, pentagon, hexagon. I don't know. I hardly ever hear people talk about a heptagon. Octagon, nonagon, not too much. Decagon, a lot. The other one's not too much. But so there you go. So those are your names. Now let's go back to this. What we're going to do today. Oops. There we go. What we're going to do today, and I'm actually going to let you use formulas for this stuff. Okay, I'll give you formulas on a quiz or a test. Okay, if you have to do this stuff. But what we're going to do, it seems like we're changing gears a little bit, but they all have to do with polygons. Okay, we're going to find a couple things. We're going to find the perimeter of these different shapes. And what else do you think would go after perimeter? Area, right. And you did this back when you were a kid, didn't you? Find the area of rectangles and all that kind of thing. Okay, so I'm not going to like start from scratch about what area is and that kind of thing, but I will just briefly give you a little review. If I was to, now I don't know if I can split this up even or not, but let's just pretend. Watch, if I was to split this into even pieces right here, and again, I know it might not look perfectly even. Yeah, it's off a little bit. Scooch it over. What, like that?
No, the other way.
The other way? Like that? Whatever, it doesn't matter. I don't care. Let's just pretend, alright? But these aren't looking like... I'll tell you what, maybe if I go like this and put some more lines in there, what do you think? I'm trying to make these into squares, and I don't know if I can or not. Now they're going to look like squares. There we go. What if I did this? Now it's kind of looking like squares, isn't it? Kind of. Alright, so here we go. So what do we do when we find the area of something? Now I started with a rectangle because a rectangle is the easiest thing to use. But when I find the area of something, I'm trying to find out how many squares, okay, literally, how many squares can you fit inside of that figure, okay? On this one, let's take a look at it. And we learned how to do this. Like if you're counting up a whole bunch of people and they were like sitting in rows and stuff, you wouldn't count each individual person, would you? You would count like the first row and you count like a column, right? So you count one column, how far back they go and how far across they go, and that's how many blocks. So I don't have to count each individual blocks. What can I count? 1, 2, 3, 4, 5, 6, 7, 8. So I've got 8 across, and how many down? 1, 2, 3. So I don't have to count each individual block. I just count across and down. What do I do to those two numbers? Multiply them together, and I get what? 24. So I got 24 squares right here. A lot of times they'll call this the length, and a lot of times they'll call this the width. So if I wanted to find out how many squares in a rectangle, that's finding the area. And so what would be my equation for area of a rectangle? Length times width. Now a lot of times they'll call this, instead of length and width, now you're probably more familiar with length and width, but sometimes they'll call one of the sides the base, and what do you think they'll call the other side? The height. So we could actually learn the area for a rectangle by what? Base times height. Okay? So an area of a rectangle, because that's going to help us with a triangle. Do you see where I'm going? Because you probably already know what the area of a triangle is, don't you? All right? But I want you to see why we use base and height. For some reason, they always teach area of a rectangle is length times width, and then the area of a triangle, they use base and height. But you could use base and height for a rectangle, couldn't you? All right? Make sense? Okay. Let's get rid of this. And this. Let's draw a rectangle one more time. Draw it more like this. Okay? Now watch. I want to figure out what the area of a triangle is. So what I'm going to do is this. I'm going to go from one corner to another. We call that a diagonal. Now I started off with a rectangle, but now what did I end up with? Two triangles. Okay? And what do you think might be true about these two triangles? They're exactly the same. Okay? They're exactly the same. I'll split this, from corner to corner. These are exactly the same. So this triangle is how much of the original rectangle? It's half, isn't it? It's half of the original rectangle. Does that sound familiar? So the area, I'll put a little T right there. What's that T stand for? Triangle. The area of a triangle is not base times height, because that would be a rectangle. Area of a triangle is 1/2 the base times the height. I'm not going to put the little X or a dot. I'll just put them right next to each other. Okay, that means they're being multiplied. So that is the area of a triangle. So what's the area? I'll put a R right here. What's that mean? Area of a rectangle. Area of a rectangle is what? BH. Yeah, we'll just go BH, base times height. Is that all right? Using BH instead of LW? You okay with that? All right. Yeah, I mean, it's probably more familiar to you because that's what you first learned, but it's the same thing, isn't it? The base and the height. Now, what has to be true about the base and the height? I started off with a rectangle here, didn't I? A rectangle's got to be what kind of a angle? It's got to be a right angle. So watch. If I call this the height and I call this the base and the height, we talked about this right at the beginning of class. These two lines are what to each other? The two lines are perpendicular. Good, you're listening. Okay, so the base and the height are perpendicular to each other. Okay, so whenever you have a base and a height in any of these formulas, they have to be perpendicular to each other. They have to form a right angle. Does that make sense? That's very, very important. I hope you're paying attention to that, especially the ones that have their head on the desk and sleeping and not paying attention. Don't see how you guys can do that day after day after day. You're missing out on so much stuff. So let's look at this. What if I called the bottom from here to here? Oh, why'd that go thick? Oh, I know why. Okay. What if I called this the base from here to here? Which one's the height? Is this slanted one right here the height?
Just go up.
No. Let's do it a different color. Go up. Up from where? The middle? Is that what you want to say? Let's do this. Let's start from the top of the triangle and go what? Let's not just say down, because that would be down. That's still down. But is that the height? Well, that's a straight line. Give me a better geometry word. Okay, yeah, but what if this triangle was slanted? It wouldn't be vertical. Perpendicular. That's the word I want to hear, okay? That this is the height. This is my height right here, and it's got to be what to the base? Perpendicular to the base. All right? So that's really important. So if this bottom is the base, then this pink-purple one right here is the height. Why is it the height? Because it's perpendicular to the base. That's very, very important, okay? And they're going to just give you what the base and height are. Okay, they'll say the base is 5 and the height is, I don't know, 3. So let's make it a better number. Make it come out even. Okay, so what if they give you the height is 4 and the base is 5? Then how do you find the area of this triangle? It's just 1/2 the base, right, times the height. What's the base? 5. What's the height? 4. That's 20. Half of 40 is, or half of 20, sorry, is 10. All right. Now, what do we do when we find the area? We find out how many squares can fit in here, right? So if this was centimeters and this was centimeters, look, what is centimeters times centimeters? What's anything times itself? Something squared, isn't it? So this is 10 centimeters squared. Should make sense, because what are we finding for area? We're finding out how many squares can you fit inside of that triangle. So how many squares could I fit inside this triangle? I could fit 10 square centimeters, right? And sometimes they'll say that. You'll see 10, and then you'll see this, SQ, and then centimeters, or 10 square inches, or 10 square feet, or 10 square miles. You probably heard that before, haven't you? It's the same thing. It's centimeters squared or square centimeters. This means the same exact thing. Brianna? Like if 1 centimeters and 1's inches? Yeah, you would convert them, but I don't think they're going to do that. But you would, yes. In order to multiply them together, they have to be the same units. Good question. Okay? I'm pretty sure. I can't say always because I don't know every single problem you're going to be doing, but I would say for the most part, yeah, they'll be the same units. Now, they may do this. They may give this to you in meters and give this to you in centimeters. They may do that. I really doubt they'll go from the English to the metric, give you 1 in inches and 1 in centimeters. But they could give you like this in millimeters and this in centimeters. Yeah, and you would have to convert to one or to the other. Exactly right. All right. So that's one formula right there, area of a triangle. Now we didn't talk about perimeter. What about perimeter? Let's say the let's just do another triangle. Just make it look like that. Okay. What if I told you that this was 5, and this was 5, and this was 3, and I asked you to find the perimeter, P for perimeter. Perimeter just means, listen to this, the perimeter just means the distance around something, right? They give you some fancy formulas in this book. I don't think you got to memorize a whole bunch of formulas for the perimeter. The perimeter just is the distance around an object. So if you look at this, if I wanted to think about it as like walking around this thing, all right? If you're going to walk around it, this is 5, and this is 3. What do we do with all those distances? Just add them up. That's it. Okay? So 5 plus 5 plus 3. right? And that's easy. That's 10. That's what? 13. Now, if this is in, let's go feet this time. If that's in feet, is it feet squared? Is it cubed? Yeah, but we're just adding though, right? Feet plus feet plus feet, okay, is just feet. All right. If I say walk 1 mile, then walk 2 miles, then walk 3 miles, it's not miles cubed. It's just miles. How many miles you walked, right? So this is just a length. This is just 13 what? Feet. Okay. There you go. Does that make sense? All right. Volume is cubed. We're not going to do volume today, though. One more thing, real quick. Bell's going to ring, but you know what? I can't believe I didn't do this. I didn't make up a worksheet today. Let's look at this. Let's do this really quick. Do you remember what the area of a circle is? The area. It's pi r squared. What's the circumference? The circumference is the distance around it. What's that? It's 2 pi r. You don't have to memorize them. You really should, but you don't have to. And I'll give you a worksheet on this when we come back on, what, Wednesday? Okay. Why not? Oh, my word. Okay. All right, well, I should give you about 5 homeworks then. We don't have class for almost a week.